Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, cycle geometry, we are going to take the seventh theorem, that is theorem number 7. So let's begin. After completing the very lesson today, my dear student, you'll be able to find the measure of the angle between a chord and a tangent at the point of contact. This is what I hope you'll be able to do after completing the very lesson today. In your favorite segment of the lesson, that is Maths is Fun, today, my dear student, I will explain what happened to these four forces. I will explain what happened after completing my lesson today if you be with me. My dear student, this is theorem number 7 for you, and this very theorem is very, very useful while solving problems in cycle geometry. So let us learn theorem number 7. The theorem number 7 says the angle between a tangent and a chord is equal to the angle subtended by that very chord, but at the alternate segment. Let me just use this drawing to explain this very theorem. In this drawing, you can see PAT is a tangent because it just touches the circle at the point E. I have here chord AB. It's just a straight line touching two parts of the circumference. This is another chord AC. This is another chord BC. But this theorem says the angle between a chord and a tangent. So in this drawing, I have angle theta as the angle between chord AB and this the tangent AT. And I also have angle gamma here. You can see it here as the angle between chord ACOCA and the tangent AP. These are the two angles, gamma and theta, that happens to be in between a chord and a tangent. So this theorem says that angle will now be equals to the angle subtended by that very chord, but at the other segment. That is the meaning of the alternate segment. So if I have chord AB, this chord AB now divides my circle into two segments. This is just one segment that contains my theta, and this is the other segment. So the chord subtended the angle at the other segment. So that very angle, like this beta, would now be equals to this angle theta. So angle between chord AB and the tangent AT, that is the angle theta, would now be equals to angle subtended by this very chord at the other segment. This is this angle beta. Similarly, if you take out this angle gamma as the angle between tangent AP and chord AC, and that chord AC subtended an angle alpha at the other segment, because this AC now divides the circle into this very segment and this very segment. So gamma is the angle between this tangent and the chord, so that chord subtended an angle alpha in the other segment. Then gamma and alpha will always be equal based on this theorem. Let me just write it. So I have theta as equals to beta. Theta and beta are equal. And I also have gamma and alpha to be equal. And the reason we usually write whenever you make this assertion is angle in alternate segment. This is the reason that you must write whenever you make this assumption. We are going to make use of this very theorem and answer problem. Let's just move and take examples. Example number 1, it says line XTY. XTY is a tangent at the point T. So it's a tangent to this very cycle at the point T. The question asked is to find the size of the marked angles. The marked angles here, I have angle Y and I have another angle X. I have this angle 43 degrees and I have this angle 67 degrees. Solution to this very problem. So you now look at the two angles X and Y. Think which one you can find first, depend on the information you have in the question. If I wanted to find X, I can find X if I know this very angle. This angle ATX. If I can find this angle ATX together with this angle X and this angle 67, will now give me angle on a straight line, and I know the addition of angle on a straight line is what AT. Let me just think how I can find this angle ATX. ATX, look at it. It's an angle between the tangent XT and the chord AT. This is the angle. And this chord ET obtained angle 43 degrees at the other segment, which means these two angles, look at them, I colored them green. The two angles are equal based on the theorem 7 that we have just learned. So ATX, this very angle, will now be equals to 43 degrees. And the reason is it is angle in the alternate segment. So this angle would now be 43 degrees. And I have these three angles, 43x and 67, as angles on a straight line. So addition of the three angles gives me 180. So I can use that to find x. So x will now be equals to 180 minus the two other angles, 43 and 67, which is this very angle. Subtracting the two angles correctly give result 70 degrees. And reason here is the three angles are adjacent angles on a straight line. So what remains is the other angle y. So to find y, let me just think how I can find y. Of course, I have x. And this ABCT is a cyclic quadrilateral. Look at it. ABCT is a cyclic quadrilateral because all the four vertices are on the circumference on the cycle. One of the theorem we have learned in our previous lessons, it says y and x are opposite angles of a cyclic quadrilateral. And the addition of those two opposite angles gives me 180. So there I can now find y because x is not. So y plus x equals to 180 degrees. Reason is they are opposite angles of a cyclic quadrilateral. So substitute x by 70 to get y. I'm going to have 70 plus y equals to 180. So taking 70 to the right hand side, y to change it to minus. You now have y equals to 180 minus 70, and subtracting 70 from 180 correctly gives a result to 110 degrees. So this is the size of the angle lettered y. Let's just move and take one more example. Example number 2, it says O is the center of the cycle, as you can see here in the drawing. BC is a tangent at the point B. So this line, the BC, is a tangent to this very cycle, and it is a tangent at the point B. So the question asks is to find the size of the angle SBO. SBO, it is this angle that we needed to find. Solution to this very problem, what you do first is to mark that very angle asked to find that is the angle SBO, this very angle, look at it. So you now mark it, look at it. This is the angle that we needed to find finally. So you know what you now do. You now check what you have. I have just this angle 35 degrees. See how I can now make use of it and some other information probably that I can see from the drawing in order to find this angle SBO. So to find this, what I can see here is this angle SBC or CBS. I can find it because this angle is an angle between the tangent BC and the chord BS. And that chord BS obtained this very angle 35 degrees at the other segment. And the theorem we have learned, that is theorem number 7, tell us that the angle between a chord and a tangent is equals to the angle obtained by that chord at the other segment. So this angle will now going to be the center as this 35 degrees. So angle CBS is now going to be 35 degrees, and the reason is it is angle at the alternate segment. So if this is 35 degrees, I think I can find this very angle right away, because from O to B is radius and B to C is tangent. One of the theorem we have learned in our previous lessons is the angle between radius and a tangent is always 90 degrees. So this angle QBC, that is from this end, QBC is now going to be 90 degrees, and the reason is radius perpendicular to tangent. So there, the addition of the two angles gives 90 degrees, that is this marked angle and this angle 35 degrees, which means to find the marked angle, simply I'll subtract this 35 degrees from the sum, which is this 90. So There I'm getting the marked angle SBO as 90 minus 35 degrees. And this subtraction done correctly, you now have answer 55 degrees. So this is the angle SBO. So with this, I have answered this very question as well. With these few examples, my dear student, I have come to the end of this very lesson. Let me just move quickly to the last segment versus fun, where I'll promise to explain what happened to this 4 force. The interesting thing about this 4 is says you can now make any number from 1 to 10 using the combinations of addition, subtraction, multiplication, and division between this group of 4 force. So if you to perform addition, subtraction, multiplication, and division, maybe 3 operations on this 4 force, in the area you now have either 1, 2, 3. You can make any of those numbers from 1 to 10. Let's just take a few examples. If I want to make 1, I can now take 4 divided by 4. Add 4 minus 4. Mind you about the mass, please. So therefore, divided by 4 gives you 1. That 1 added to 4, you now have 5. And 5 minus 4 in the area, you can see you have 1 in the end. If I want to make a 2, what I'm going to do, I will now have 4 minus bracket inside the bracket 4 plus 4, then the bracket divided by 4. So minding our border master there, the bracket first 4 plus 4, you have 8. Next is division, so you now divide 8 by 4. That gives you 2. So you now have 4 minus 2. You can see you have 2 in the end. If I want to make a 3, what I'm going to do, I'll now have a bracket inside the bracket 4 multiplied by 4 minus 4, and that bracket divided by 4. So minding our border master also, inside the bracket is what you do first. So 4 times 4 gives you 16. 16 minus 4, you now have 12. So that 12 divided by 4, you have a 3. You can see it. If I want to make a 4, so what I'm going to do, I'll now have 4 plus 4 multiplied by the bracket inside the bracket is 4 minus 4. So minding our body mass, the bracket first. 4 minus 4 is 0. That is 0 multiplied by 4 is 0. So 4 plus 0, you still have 4. So you can make a 5, 6, 7, 8, 9, after 10. You can try those ones using this 4 force and using either multiplication, division, subtraction, or division. Math is amazing. We see more of these things in mathematics in our subsequent lessons.